Right. This is the question that we stopped last week. Last week we stopped with this question under the graph section, right? So it tells us in question number 96, it tells us 600 questions due. It tells us an object travels first 200 seconds with the constant velocity of 20. Within the next 20, within next 20 seconds, the velocity increases from 20 to 30. So there's an acceleration. After that, the vehicle travels with the obtained velocity of 30 meters per second for a period of 200 seconds. And finally, during the last 30 seconds of time period, the object comes to rest. So what kind of motion is this there? Constant velocity, acceleration, constant velocity, and deceleration. Right? So if this is 0, this is 0 to 20, 20 height. If this is 0, this is 30, therefore this height is 30. If this height is 30, this should also be 30. Am I right? And if I mark this angle as alpha, I can find tan alpha is equal to the acceleration. From a velocity type graph, gradient is the acceleration. If I mark this angle as beta, I can find the deceleration. So if this is 30, this should also be 30, right? So both should be 30 each. 30 and this is 30, so you can find the deceleration. Here you can find the acceleration. If this is 20, this should be 20. And if this is 30, this is 20. So it means this height is 20. So this should be 10. It should be 10, right? So this is what we have already discussed. I have just drawn it for you to recall your memory about the question. Here we want to draw the displacement time graph. We have answered all the things of this question, but we did not complete the displacement time graph. So here we have, this is constant velocity, this is constant acceleration, this is again constant velocity, and this is constant deceleration, right? So you can use any letters to indicate the motion. If you have not drawn this graph, I'll give you about 5 minutes, draw this. If you have not drawn this graph, okay, if you have not drawn this graph, please draw it there. So if you have not drawn this graph, please quickly draw it. I'll give you 5 minutes. Like I think time is enough for you to draw this velocity time graph. I gave that time to some of the students who were not able to draw it that time. So can you hear me properly before I start the explanations? Could you please tell me whether you are able to hear me clearly or not?
Yes, sir.
Right. Thank you, dear. Now listen, dear. So during the first 200 seconds, it travels with the constant velocity. How do we represent constant velocity in a displacement time graph? So now we are going to draw a displacement time graph, right? So time is indicated by simple t. Displacement is indicated by s. Unit is meter. So sometimes people may use the term st graphs for the velocity time graph. Sometimes people may use st graphs, right? So because we use s for velocity, s for displacement. So that's why some people use the term st graphs, right? So during the first 200 seconds, the object travels with a constant velocity. Constant velocity is indicated like this in the st graph. So let me mark the time as 200. If you want, you can find the displacement here, right? If you want, you can find the displacement S1 from this graph. From velocity time graph, how do you find the displacement? Just take the area under the graph. For a velocity time graph, area under the graph is the displacement. So you can easily find this S1 if you want. Then during the next 20 seconds, there's an acceleration. So in a velocity time graph, acceleration is indicated by a straight line. In a velocity time graph, acceleration is indicated by a straight line. In a displacement time graph, acceleration is indicated by a curve like this, right? So then it obtain displacement of S2, right? This is during the next 20 seconds. During next 200 seconds, the object travels again with the constant velocity. So constant velocity is indicated like this. Constant velocity is indicated like this. So this is what happened during the next 200 seconds, and finally it decelerates and comes to rest. So deceleration indicates like this. Deceleration is indicated like this kind of a curve. So this is what happened during the last 30 seconds, but I will explain further. I'll give you more descriptions about displacement time graph. First you complete this answer. After that I'll give you more descriptions, more explanations, right? This is the displacement time graph for this velocity time graph. Completed here. So if you want, you can calculate this S1, S2, S3, S4 easily from this velocity time graph. That's just area under the graph. Draw it. Right, is the time enough for you to draw the graph here? Who wants any more time to draw this graph? Am I? Right. So in a velocity time graph, this is how we represent constant velocity. In a displacement time graph, constant velocity represented in a different way. So that's what I am going to explain today. In a velocity time graph, acceleration is represented by a straight line like this, an inclined straight line like this. But in a displacement time graph, acceleration is a curve. Right? This is constant velocity, this is deceleration. So I am going to give a note about these shapes: constant velocity, acceleration, and deceleration. So that's what I'm going to do next. So please check when you have drawn all the things. If you have drawn all these things, I can I'll erase these things and I'll explain these shapes. You need my help to understand these shapes here. If you have drawn all these things, send a message to my Zoom chat saying done. Then I'll explain everything. Okay, dear? Am I? Right, I think time is enough. Look at board here. So you should identify 6 different shapes for the graphs lesson team. I'm going to give you those 6 different shapes, and we can prove all these shapes also. Right? For the graphs lesson, you should remember 6 different shapes. Actually, you have learned those things even in O levels. The problem is you have forgotten them now. You have learned those shapes in your O levels. Unfortunately, you have forgotten them, right? Therefore, I should recall your memory by giving those shapes. Look at board here. right? Actually, there are three different kinds of motions you should that you want to remember. There are three different kinds of motion. You should remember those motions. The first kind is the constant velocity. So I'm going to give you the shapes as a summary, right? If you do not remember this these shapes, or still you are confused with these shapes, so I can arrange another day to explain the shapes of these graphs. The first thing that you should remember is constant velocity. Constant velocity. How do you represent constant velocity in a velocity time graph? That's the graph that we have learned last week. In a velocity time graph, it's so simple to explain, represent constant velocity. Just a straight line like this. How do you represent the same motion when an object is moving with the constant velocity? This is how we represent its motion in the velocity time graph. How do you represent the same motion in a displacement time graph? For the displacement, let me use the letter S. For the velocity, for the time, we use simple T, right? So in a displacement time graph, the constant velocity is indicated something like this. And look at board. If I mark this angle as theta, from a velocity time graph, the gradient of a displacement time graph. The gradient of a displacement time graph is equal to the velocity. Right? This is what you will remember. So therefore, velocity equals gradient means tan theta. That's it. So two different graphs, two different shapes. For a velocity time graph, this is constant velocity. The constant velocity is represented in a displacement time graph like this. You have learned all these things even in O levels, but if you do not remember or if you are confused with this, send a message to my WhatsApp. I can arrange another day to read these things. Right. Please draw. This is the summary number one. Like that, we are going to draw two more graphs, two more sections. So one section has two graphs, three sections. There will be six graphs. You have to remember the six shapes. And I'm going to explain those six shapes, six different graphs by doing some questions. That's what I'm going to do. Right. Draw them there quick. Start saying summary. Here, S4 displacement, right? We have used the letter S4 displacement. Right. The second kind of the thing is constant acceleration. How do we represent constant acceleration in a velocity time graph? Right? Velocity time graph, V for velocity, T for time. And how do you represent constant acceleration in a displacement time graph? T for time, S for displacement. So this is what we are going to learn next. Summary number two. First, you complete summary number one. Right, constant acceleration represented in a velocity time graph like this. If I mark this angle as alpha, what is tan alpha? Tan alpha is the gradient of a velocity time graph. So look at board here. Gradient of a velocity time graph. What is it here? Two different graphs, two different things. That's the point. The gradient of a displacement time graph is velocity. The gradient of a velocity time graph is acceleration. That's what you will do. That is acceleration. Okay. So if I want to find the acceleration, I should find tan alpha. So that's how we find. In a displacement time graph, acceleration is represented in a different way. Acceleration is represented like this, right? Velocity time graph, this is how we represent constant acceleration. Displacement time graph, this is how we represent constant acceleration. The gradient of this velocity time graph is acceleration. Therefore, if you find tan alpha, that is equal to acceleration. Got it? Completed here. So two different graphs, two different meanings, right? Right. I think you have drawn them. Now, somebody please tell me how to find the displacement from a velocity time graph. How do you find the displacement from a velocity time graph? Lamai?
Area under the graph.
Very good. So displacement, very good. So displacement equals area under a velocity time graph. Area under a velocity time graph. Displacement is area under velocity time graph. That's it. Complete this note. This is the summary number 2. I'm going to draw 2 more graphs. We are going to use all the 6 graphs to solve the problems. Once we solve some problems, you will be okay with the lesson. Start here. Right. The third and last two graphs, the third set. Look at board. How do you represent constant deceleration? Constant deceleration in a velocity time graph. How do you represent constant deceleration in a velocity time graph, and how do you represent the same constant deceleration in a displacement time graph? That's what we are going to learn. Can you draw them without my help here? Do you remember your past? Check that you remember the constant deceleration shape in velocity time graph and constant deceleration shape in displacement time graph. You were trying draw them before I draw them. You were trying. Constant deceleration. Constant deceleration. In a velocity time graph, constant deceleration is represented like this. In displacement time graph, constant deceleration is represented like this. Curve bend to this direction. And look at board. If you find this angle, here we can't say gradient, as people know the reason. If you find tan beta, right? So this is how we represent constant deceleration in a velocity time graph. If you find tan beta is equal to Lamai.
Deceleration.
Deceleration, very good. So still the relationship is true. So deceleration. Sorry. Deceleration equals tan beta. What about displacement here? Displacement is whether it is constant velocity, constant acceleration, no constant deceleration, whatever it is, velocity displacement is always equal to area under the graph. So displacement is always equal to area under the graph. Area under the graph. Complete this here, quick. So this is the third set of the summary. We have 6 graphs. We have drawn 6 graphs. We are going to use those 6 graphs to solve problems. Complete. Right, now let's use these graphs to solve some problems. I think you remain, I think you are okay, but for you to be okay, for you to be 100% okay with these shapes, we want to do some questions. Right. Without doing questions, I don't think that you will, that you can understand the things. Can you hear me properly? Because I asked the same question again and again because we had a data connection issue today. Can you hear me properly, Lamai?
Yes, sir.
Right. Thank you, dear. Thank you very much. So let me show you the tube. Can you see this? So this is our 600 questions tube, question number 96. Right. A car travels with the we have answered this 90. This is the question actually we discussed at the very beginning of the class even. Right. So this can you see this clearly, dear Lamai?
Yes, sir.
Right. So 96 we have completed. Let's try for 97. Right. Right. I want to confirm whether you are able to see the question properly. Therefore, can somebody unmute the mic and read the question? Can somebody unmute the mic and read the question?
The diagram shows the velocity time graph of two cars, A and B, traveling in a straight road. When B starts to move, A overtakes it. After some time, B meets A acceleration of B. Third one, the distance that A travels before B meets it again.
Right. Thank you very much, dear. Thank you very much. The diagram shows the velocity time graph of two cars, A and B, traveling in a straight road. How many cars are there? There are two cars. When B starts to move, capital A overtakes it. Okay. After some time, B meets A again. Find the acceleration of B, deceleration of B, the distance that A travels before B meets it again. So what are the things they have given? B accelerates for a period of 50 seconds. It reaches to a velocity of 12. After that, it has a constant velocity of 12, decelerates and comes to rest. So A travels with a constant velocity of 9 meters per second. That's the meaning, right? Okay, let me use my normal whiteboard. If you want to any more time to draw these graphs, please take a screenshot. I'm going to erase everything. I'm going to discuss question number 97 of my 600 questions tube. So if you want, please take a screenshot. If you want any more time to draw these things, just take a screenshot. Right. What are the details that they have given us? Look at board here. We should try to identify the story given in the question. Before we answer question, we must be able to identify the story here. Without understanding the story, right, we cannot answer the question, isn't it? So according to this question, right, according to this question, there are two vehicles. There are two vehicles. Right? They're traveling along a straight line road. The first vehicle is vehicle A. I don't care whether it is a car, bus, or whatever it is. This is A. There is another vehicle, it is B. So if you check the graph, you should see something like this. Initially, during the entire motion, not only initially, during the entire motion, the vehicle A has a constant velocity of 9. If you check the velocity time graph, this is what you will see. During the entire motion, A has a constant velocity of 9. So my question is, what should be the initial velocity of A? Somebody unmute the mic and tell me what should be the initial velocity of A?
9 meters per second.
9 meters per second. Very good. It always has a constant velocity of 9 meters per second. Correct. If you check B's graph, you will see something like this. Let me use black color for it. You will see that it accelerates during the first 50 seconds. During the first 50 seconds, it accelerates and obtains a velocity of 12. So this is the 0 point. So my question is, what is the initial velocity of B?
0 per second.
0. Very good. Excellent. Initial velocity of B is 0. Very good. Initial velocity of B is 0. Right. After 50 seconds, what is the velocity of B, dear?
12.
12. After 50 seconds, let's say B is somewhere here. I don't know the position of A. It has a velocity of 12. It has a velocity of 12 after 50 seconds. After that, the graph tells us B travels with a constant velocity of 12 for a period of, let me check the question. B travels with a constant velocity of 12 for a period of 70 seconds. So this is 120. This is 50. That's what should be this gap there, Lamai?
70 seconds.
Sorry?
70 seconds.
70 seconds. Very good. 70 seconds. So during the next 7 seconds, it travels with a constant velocity of 12 and finally it decelerates and comes to rest. Right? So this is the velocity time graph which is given in the picture. So if you look at the motion of B, if you are looking at the motion of B, right? During the next 50 seconds, during the next 70 seconds, B will travels with the velocity of 12. Within the next 70 seconds, the vehicle B will travels with the constant velocity of 12. Finally, B comes to rest. Finally, B comes to rest. So this is the motion, right? During the entire time period, so what is this? The 120 and 180. If this is 180, if this is 180, what should be this gap there? Now, what should be this gap?
60.
60, right? Very good. So this should be 60 because this is 120. Yes, right. So
story of B is very, very clear. It's very easy to understand the story of B. Both vehicles starts to move. Both vehicles starts to move at the same point. The difference is B starts to move at rest, S starts to move with 9 meter per second, and it continues the motion like this, right? I want this line, wait, I'm going to draw the motion positions of A after each and every time interval. So I am going to draw, listen, I'm going to draw some figures here. I'm going to draw the positions of A here. I have drawn only the positions of B because that's the only thing, that's the thing which is given the graph properly. So this is the graph of B. This is the graph of B, right? Let me mark some points to explain the motion. Let me take this point as X, this point as Y, and this point as Z, right? X, Y, Z. And let me take this point as P, this point as Q, this point as R, and this weight, and this angle as alpha, this angle as beta. One more point, and let me mark this point as X. Let me mark this as X dash. This is Y. Let me mark this as Y dash. This is Q. Let me mark this as Q dash. This is R. So let me mark this as R dash. So sometimes we will need this X, Y, Z, P, Q, R, X dash, Y dash, P dash, Q dash future. And I want to draw the positions of A here, right? So draw both. This is the question number 97 of our 600 questions tube, right? I want to draw the positions of A, so you should keep the motion, keep the space. Draw them all. Draw them all, start. Once you have drawn the figures and the graph, send me a message to my Zoom chat saying done, so I can start explaining and I can go further. Once you draw these things, send a message to my Zoom chat. I'm waiting. I'm waiting until you reply. Right. While others draw in this graph, can somebody tell me the acceleration of the vehicle B? Can somebody find it there? The acceleration of the vehicle B. How do you find this here? Naman? I want to find the acceleration of the vehicle B. There are two methods. If you can apply equally plus any, but from the graph, how do you find it?
See the gradient?
Yeah, gradient. So that is tan alpha, right? Very good. So the acceleration of vehicle B is tan alpha. So tan alpha means opposite side. Opposite side is YZ divided by the adjacent side, that is XY. What is YZ, dear? What is YZ? If this is 0, if this is 12, so what is the height YZ? This is 9. This height is 12. So therefore, YZ height, dear?
12.
Yeah, it's so simple, eh? Very good. So it's so simple. See? This is 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you want, you can mark these heights there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So YZ height is 12. What is XY length there? What is XY length?
50.
XY length is 50, yes. So acceleration is 12 divided by 50. 12 can be divided by 2, that is 6. 50 can be divided by 2, that is 25. So 625 meter per square second is the acceleration. For my equations, this is enough. For my equation, this is enough, but in the exam, you have to divide 6 by 25. For my equations, always keep the answer as a fraction. Complete it here, quick. Right. Then how do you find the deceleration? This section, how do you find the deceleration? Lamai? Deceleration of B.
Now I have to find deceleration of B. Hello. That is tan
Tan beta.
beta. Very good. So deceleration is tan beta.
Beta, sir.
Yes, very good. Can you find it without my help? This is angle beta, right? Angle beta. Can you find deceleration without my help and send your answers to my Zoom chat here? Find the deceleration. Use this equation. Oh, deceleration equal tan beta. Can you use this equation? Sorry. Can you use this equation? Find the deceleration and send to my Zoom chat right here. Find the deceleration and send your answers to my Zoom chat. I'm waiting for your answers. What about my voice here? Is it clear or is it lagging? Is my voice clear or is it lagging?
Lagging, sir.
Right. Tan beta is opposite side, that is PQ, divided by adjacent side, that is QR. So tan beta is opposite side PQ over QR. Can you see the board clearly?
Yes, sir.
PQ, you see this PQ height, just look at board. The PQ height is exactly 12. This is 12, right? So PQ is 12, QR is 60. So PQ is 12, QR is 60. 12 divided by 60 is 1.
12 divided by 12 is 1, 60 divided by 12 is 5. So the deceleration is 1 over 5 meter per square seconds. Who got this deceleration answer correctly? Lamai, who got this answer? Right now, I want to find something like this. I want to find the displacement of the vehicle after 50 seconds and displacement of the car A after 50 seconds. I think your time is enough, so I erase this side. I erase this section. Look at board. I want to find. Look at board. Displacement of capital B after 50 seconds. So displacement can be obtained by area under the graph. Area under the graph means this section. This is X, this is Z. So area under the graph means this area. I'm talking about the vehicle B. So displacement after 50 seconds is area under the graph. Area under the graph means area of XYZ triangle. Can you do the rest without my help and find the displacement of the vehicle after 50 seconds and send you answers to my Zoom chat here? Find the displacement of the vehicle during the first, just after the 50th second or during the first 50 seconds. I think you didn't hear me, right? I asked you to find the displacement of the vehicle capital B during the first 50 seconds. The displacement is equal to the area under the graph. If you consider the first 50 seconds, the graph is a triangle, XYZ triangle. Therefore, area under the graph means area of the XYZ triangle. So you just want to find the area of the XYZ triangle, and that is the displacement of the vehicle capital B during the first 50 seconds. Find that and send it to my Zoom chat. Send your answer to my Zoom chat. Start there. Lamai, can you hear me?
Yes, sir.
I asked you to find the displacement of vehicle B during the first 50 seconds. Who found that answer? Please raise your hand if you have found the displacement of vehicle B during the first 50 seconds. Lamai? Right, so area of XYZ triangle mean area for triangle is half into base, that is XY, into perpendicular height, that is YZ, that is YZ. So half into XY, that is 50. YZ, so YZ is 30, you see, this height is 30, you must be able to recognize it. This is just 30, you see. Always this gap between these two lines 30. So YZ is 30. So it's very simple. This is 50. 30 divided by 2. Half. So 30 divided by 2 is 15. So 15, you can write the 0 here. You can multiply by 5. Write the 0 here, multiply by 5. 5 times 5, 25. 2 remaining. 5 times 1, 5 plus 2, 750. Who got this answer? Who got this answer? Please raise your hand up.
Sir, why is
So
it?
that is sorry. That is not 30. Sorry, this is not 30. This is 12. Sorry, it's 12. 12. So it's 12, right? Sorry. So sorry. It's 12. So XY 50, correct? So YZ is 12. YZ is 12. Sorry. Or 12 divided by 2 is 6. 12 divided by 2 is 6. And then 6 times 0, 0, 6 times 5, 30, 300. Who got this answer? Please raise your hand up. If you got the displacement of the vehicle B during the first 50 seconds as 300 meters, please raise your hand up. Everybody, please. I want to check the students who got this answer. Yes, good. Nice. Now I want to do the same thing to the vehicle capital E. That's what I want to do. Look at what here. Can you all try to find the displacement of capital A during the first 50 seconds. Displacement of B, not after, sorry. Not after the displacement of B for 50 seconds. So displacement of A for the 50 seconds. This is not after, this is for 50 seconds. How do you find it here? And it's again area under the graph, right? So which area there? I'm to A, the vehicle A travels with the constant velocity of 9. So I want to find the displacement of A during the first 50 seconds. So area of A means this here. See this part. So what is this here? What is the shape of this section? X is Z, Y Z, Y. So X, Y, Y Z, X dash. What is it? It's a rectangle. So that is the area of X, Y, Y dash, X dash rectangle. Can you find the area of this X, Y, Y dash, X dash rectangle? That is the displacement of A during the first 50 seconds. Find this and send your answers to my Zoom chat. Start here. Find the answer and send it to my Zoom chat. Start. I'm waiting for your answers, dear. So displacement of vehicle A during the first 50 seconds is the area of x, y, y dash, x dash rectangle. Area for rectangle is length into width. Length is xy, width is x, x dash. So length is xy, width is or height is x, x dash. So xy is 15. X dash is 9. So 9 times 5 is 45, 450 meters. So within the first 50 seconds, A has traveled a distance of 450, B has traveled only 300. So if I mark this displacement of B, so this is 300. So it has a displacement of 300 meters after 50 seconds, but after 50 seconds, A is somewhere here. It's traveling with a constant velocity of 9 meters per second, and it has traveled a distance of 450 meters. So it means still B is behind A. Still B is behind A. Am I right? That's a gap. Got it? So after 50 seconds, yeah, like this. So this is the displacement for 50 seconds. After 50 seconds, A is here, B is there. Got it? Completed here? Is this clear, or may I again explain? Do you have any doubt? Right. Thank you, dear. Now I'm going to ask you to find displacement of B. Look at what displacement of B during displacement of B after 100, and this is 50, this is 70, after 170 seconds. So that is area under the graph. So now we have found the displacement of the first 50 seconds, that is area of xy. We have already found the displacement. So it means you have to do two things. Displacement during the first 50 seconds, that is the area of XYZ triangle. We know, we have found it actually. We have found that as 300. Nothing to do, nothing to worry about it. During displacement of the vehicle B during the first 50 seconds is 300 meters. We have already found. The displacement of vehicle B during the next 70 seconds, that is the area of YZ PQ rectangle. So area of YZ PQ rectangle. Am I right here? Can you identify these things? XYZ triangle. Area of, listen here, area of XYZ triangle. XYZ triangle gives the displacement during the first 50 seconds. We have found it as 300. Area of YZ PQ rectangle, this area, gives the displacement of vehicle B during the next 70 seconds. 50 plus 70 is, 120. 50 plus 70 is 120. So displacement of vehicle B just after 120 seconds is area of XYZ triangle plus area of YZ PQ rectangle. This is the thing that you will find. Area of a rectangle is length, that is YQ length into width, that is YQ into YZ. Can you find this and send your answers to my Zoom chat? Find the displacement of vehicle B after 120 seconds. That is given by two sections of the graph, X, Y, Z and Y, Z, P, Q. Area of X, Y, Z we have already found, that is 300. The only thing that you will find is this. Find this and send me the total displacement of the vehicle for 120 seconds. You can use the word after, or you can use displacement of B for 120 seconds. Can you find this and send to my Zoom chat here? Give a try, Lamai. If you have found the displacement of vehicle B for 120 seconds, send your answers to me here. I'm waiting for your answers. Some students, they have already sent me the answers. I'm waiting for your answers also. Quickly here. What is the displacement of the vehicle B after 120 seconds? Or during the time period of 120 seconds? That's what I'm asking. So this is 300. We have already found it, so I do not worry about it. YQ. YQ is length into width is the area of a rectangle. YQ is 17. YZ. YZ is 12. YZ is 12. So this is 300. 300 in sorry, not into 300 plus 300 plus just write the 0 here. Just write the 0 here and multiply by 7. Write 0 and multiply by 7. 7 times 2, 14. 1 remaining. 7 times 1, 7 plus 4 is 8. 0. 7 times 2, 14. 7 times 1, 7 plus 8. So that is 0 plus 0, 0. 4 plus 4, 8 plus 3, 11. 1140 meter. 1140 meter. Who got this answer? Who got this answer? Please raise your hand up in the Zoom chat. Okay, very good. Right, now your turn. Please do the same thing to the vehicle B. Sorry, vehicle A. Do the same thing. What you want to do? The displacement of A for 120 seconds. The displacement of A for 120 seconds. That is the area of X, X dash, Q dash, Q. Entire area. This entire area. Everything. This total area. Right, so that is area of, we want to find the displacement of A for 120 seconds is area under the graph, that is area under the graph, that is area of, that is the area of X, X dash, X, X dash, Q dash, Q. Q dash Q rectangle. Can you find this here? This is Q. This point is Q, right? So displacement of vehicle A during after 100 milliseconds is the area under the graph. Area under the graph means this area that is the area of x, x dash, q dash, q. Find this and send to my Zoom chat. Find this and send your answer to my Zoom chat. Start here. And who tried to answer this question at home, dear? Who tried this question at home? Kamai? Right. It's not easy to find the time that vehicle B overtakes A. You cannot find it that much easily. At once, you can't find the time that B overtakes A, right? Because we have found that displacement of B for after 100 milliseconds is 1140. So it means this distance. Look at board. It means 50 seconds plus 700 seconds. So it means this displacement is, this is what we have found earlier. This displacement is 1140 meters. Right. So this is after 120 seconds. So after 120 seconds, where will be B? Where will be the vehicle A? After 120 seconds, the vehicle B has traveled a distance of 1140 meters. That's what we have found. And after 120 seconds, where will be A? So we have to find this displacement, right? So area of x dash rectangle means x dash, q dash, q. So that is length into it. Length is x cube. Length is x cube. Width is x dash. X dash. So x cube is 50 plus 70. 50 plus 70, 120. X cube is 120. X dash is 9. You have to multiply this. So if you multiply this, you get 9 times 0, 0. 9 times 2, 18. 1 remaining. 9 times 1, 9 plus 1, 10. 1080. So what do you think there? What do you think? Who got this answer? First raise your hand up. Who got this answer? Who got the displacement of A after 100 milliseconds is 1080? Lamai? Right. Interesting. Very good. Happy. So it means still vehicle A is behind. Sorry. Now A is behind B. A is somewhere here. This is A. It travels with the velocity of 9 meters per second, right? A has traveled a distance of 1080 meters for 120 seconds. So now B is leading. B has traveled 1140 meters for 120 seconds. A has traveled only 1080 meters. So it means definitely in somewhere after 50 seconds, after some time the 50 seconds, B has overtaken A. So we have to find that exact time duration. So this is the story. Please complete the figure. Now my velocity time graph cannot be used any further. So the thing is, after 120 seconds, A has traveled a larger distance. Sorry, B has traveled a larger distance than A. So it means now the vehicle B has overtaken. It has overtaken. But we want to find the exact time slot at which the time that the A overtakes B. Right? You complete the figure here. You complete the figure. So this is not an easy question, right? All these questions are in the real examination level questions. Even one question maybe take 1 or 2 hours to explain even a single question. These are not so simple ones. Right. Learning something and examination is somewhat the different cases here. So once you have enough experience, you don't want to write this much of things. That's what I'm going to explain next year. The only thing that I wanted to show you how to find displacements at different time regions. During different time intervals, you have different displacements. And the other thing I want to tell you that at the end of 120 seconds, B is leading and A is behind B. So, but you can understand that once you have done a lot of questions, you may have the ability to understand that without doing these calculations. Without doing these calculations, you get the ability to identify that B will be leading after 120 seconds. You get that ability by doing questions. But now we are learning, so we write all the possible things for us to understand. Once we understood, once we do a lot of questions, you don't want to do this kind of things to get the answer. Actually, you don't want. And I'm going to show you the next the thing that you should really do in the examination. I erase these things and I'll show you how to do the question in the exam without writing this much of things. Right. Okay, may I erase all these things because I want more space for the answer. Now I may erase all these things. Hello. Who wants more time to draw these things? Draw and write these things. Please raise your hand up. If you want any more time to write and draw these things, please raise your hand up. Right, I erase all these things and I'm going to explain the story much easier than this. Look at it. This question is much more easier than these things. I just wanted to give you some practice of finding displacements. Now you have some idea. Look at board here. Look at board. Right. Now you must talk to me. When I ask questions, you must talk to me. Right. Both vehicles starts the motion at the same place. Both A and B start their motions at the same place. The only difference is vehicle B starts the motion at rest, but vehicle A starts the motion with a velocity of 9 meters per second. 9. Can you see my time? It starts the motion with a velocity of 9 meters per second. According to the graphs, we have found that after 50 seconds, A has traveled only, sorry, I don't remember it. After 50 seconds, what is the displacement of B, dear? What is the displacement of B after 50 seconds? Somebody please tell me.
300 meters, sir.
200 or 300?
300.
300. Okay, good. So after 50 seconds, right, B has traveled a distance of 300 meters for 50 seconds. What is the distance traveled or the displacement of A after 450 seconds? Lamai?
450.
150. So it means A is still leading. Am I right? A is still leading, right? Even after 50 seconds. So if you consider the story of B is moving with the velocity, I don't know the velocity of B. So A has traveled 400 and where can I write? It has traveled 450 meters for 50 seconds. But if you think about 120 seconds, what is the displacement of B for 120 seconds here? Displacement of B for 120 seconds? Displacement of B for 120 seconds, how many meters do you? Can't you hear me?
1140, sir.
1140 meters. So it means, but after 120 seconds, A has traveled only 180, 1080. So it means B will overtake. Now, my question is, let's say after, right? For the listen here. Now we are okay for the first 50 seconds. My question is this. My question is this. Listen to me carefully. Listen to me very carefully. Right, B is traveling with an acceleration. B is traveling with an acceleration, therefore its velocity of B increases with the time. Let's say after capital T seconds, this is 50. T1 is 50. T2 is, let's say, capital T seconds. After capital T seconds, let's say B is here. B is here. And we know after 50 seconds, we know the velocity of B is 12. We know this 12 meters per second. Right? So after capital T seconds, 50 plus capital T seconds, velocity is 12. Let's say it is here. Let's say this is T2, this is S2 meter. Let's say at the time B reaches to this dotted line. Can you see the board? Yeah. At the time B reaches to this dotted line, let's say A is also at the same dotted line. Then what will happen? Now what will happen? A and B both are at the same place. Now what will happen? A has a velocity of 9 meters per second. B has a velocity of 12 meters per second. Now what will happen? Both are at the same dotted line place. So what will happen here? Samaya?
Displacements are equal.
Yeah, displacements are equal. What about the velocities? B has a larger velocity than A, so it means at this point B will definitely overtake A. Am I right? So total distance traveled by A and B is 50 plus T seconds. This is 50 seconds. This is capital T seconds. Can you understand? So the time duration, look at what, if you consider this, the time duration, total time is 50 plus capital T seconds. Both vehicles travel the same distance of simple dv. I don't know what the simple d is. Can you understand? They start the motion at this point and they have reached to the same point after 50 plus t seconds. After 50 seconds, A has a displacement of 450, B has a displacement of 300 meters, but after 50 plus capital T seconds, both have the same displacement, both have reached the same point, but now B has a larger velocity than A, therefore B will overtake A at this point. If I want, I can name this place, starting place, as I can use any letter. So let's say starting place as we have used P, Q, R, S, T, everything. You can use any letter, right? Would you please draw this diagram? Would you please draw this diagram? After that, I'll explain the story. Draw it. These are real examination questions. You need a higher attention to understand this. And this is the diagram that you want to draw in the exam, not the previous one. This is what you want to draw in the exam. Right now, how do we represent this story? How do we represent this story in our graph here? On the graph, how do you represent? Look at what here. The graph is the velocity time graph. Look at what. The velocity time graph of A is very simple. It's just a straight line. It travels with the constant velocity of 9. That's nothing to think about it. Right? So we have found that this is the graph of A. It has a constant velocity of 9. So there are two sections here. This is the motion during the 50 seconds. So after 50 seconds, A has a displacement of 450 meter, B has a displacement of 300 meter. After 50 seconds, we have considered another capital T seconds. So within the next capital T seconds, A travels with the velocity of 9 meter per second. But what about B here? If you consider B, it accelerates during the first 50 seconds and it obtains a velocity of 12. What is the story of B here? During the first 50 seconds, it travels with the constant velocity, constant acceleration, and it obtains a velocity of 12. After that, it travels a constant velocity of 12 for next about 70 seconds. Now this capital T is less than 70, right? So I can find, look at what this is the graph of A, right? Graph of B. Now I want to find, I know the displacement of A during the first 50 seconds, I know the displacement of B during the first 50 seconds. I want to know the displacement of A. I want to know the displacement of A during this capital T seconds time period. And I want to know the displacement of capital B during this capital T seconds. That's what I want to do. So now I'm going to listen in. Now I'm going to edit the two statements. Listen to me, don't write anything. Don't write anything. This is what you really want to do in the exam. I want to find the displacement of B for, look at board, 50 plus capital T seconds. 50 plus capital T seconds. Now we already know that area for 50 seconds is 300 meters. There is nothing to it. Right? I'm talking about B. Then area of displacement of B during the next 50 seconds, capital T seconds, is the area of this huge triangle. What is the, shall we give a name for this triangle here? Let me name this triangle as simple A, simple B, simple C, and simple D, right? So displacement, listen to me carefully, displacement of B during the first 50 seconds, 300 meter, we have already found it. And the displacement of B vehicle, this is B, displacement of B vehicle during the next capital T seconds is area of ABC, all are simple letters, ABCD rectangle. Listen to me carefully. So now area of ABCD rectangle is length into width, that is BC into BA, BC into BA, length into width, BC into BA. BC is capital T, BA, BC is capital T, BA. How can somebody tell me this BA height here? What is this BA height, Lamai? What is this BA height? Simple AB height, ABOBA height, Lamai?
12.
12, very good, that is 12. So this is T into 12, right? So the displacement of vehicle B during the time period of 50 plus capital T seconds is 300 plus T to 12 is 12T. Let me take this as my first equation. You have drawn this figure. Now you draw this graph, a new graph to indicate the new section of the motion, and then you write this. And we are going to do the same thing for A next time. Start there, quick. Please write them all.
Sir, can you send a photo of the boat?
Sorry, dear.
Can you send a photo of the boat to the
Yeah, if
WhatsApp?
you have it, yes, dear. Sure, why not?
Thank you, sir.
Right, Lamai. Let's do the same thing for A. Displacement of, we are going to do the same thing for the vehicle A, right? Right. So within the time of 50 plus t seconds, the vehicle meet each other. Within the time duration of 50 plus capital T seconds, both vehicles have traveled the same distance, right? So displacement of A4, look at board, the displacement of A4, 50 plus capital T seconds. So what is that here? It is just this area, am I right? This is the area which I have shaded. This black color shaded area is the displacement of vehicle A. No need to even mark it, right? So displacement of the vehicle is area under the graph. Area under the graph. So that area is length into width. Length is 50 plus capital T. Length is 50 plus capital T. Width is, this is just 9. Width is 9. Length is 50 plus T. Width is 9. So let me remove the brackets. 9 times 5, 45. That is 250. 9 times T is 9 capital T. 9 capital T. So let me take this as 9 times capital T. So write that one here. We have found the displacement of vehicle B within the time duration of 50 plus capital T seconds, and we have found the displacement of the vehicle A within the same time duration of 50 plus capital T seconds. At the end of these 50 plus capital T seconds, both vehicles are displaced, but B has a larger velocity than A, therefore B will overtake A. That's the story. Write them all here quick. Right now, you see here, after 50 plus capital T seconds, displacement of A equals displacement of B. That's what you're going to write. I want to erase this figure. I want to erase this figure. If you want to take a screenshot, I'm going to erase it. I need some more space to draw it, so I'm going to erase the figure. If you want any more time, just take a screenshot. Right. Look at the board. Right. So the thing is, after 50 plus, or you can say just after, that is much more better. Just after 50 plus capital T seconds, right? The story is displacement of capital E equals displacement of capital B.
After 50 plus t seconds, displacement of capital A is this. After 50 plus t seconds, displacement of capital A is 450 plus 90. 450 plus 9 times t. After 50 plus capital T seconds, displacement of B is 300 plus 12 times t. 300 plus 12 times t. So I'll take 300 this side, 450 plus 300 come this side as minus, plus 300 come to this side as minus 300. 12t plus 90 come this side as minus 90. I just interchange the names. 450 minus 300 is 150 equals 12 minus 9 is 3. Just take 3 to this side. 150 divided by 3 equals capital T. So it means capital T equals 15 divided by 5, 3 is 5 and 50 seconds. Am I right? So we have found the value of capital T. So at that time, B will overtake A. But we won't write one more thing. First you write this, we should write one more sentence to earn full marks. Write them all there quick. And if you have any doubts, you can send a message to Zoom chat. Even you can unmute the mic and ask. Right. So the only thing that you write is this. Right. So what is the total time taken for vehicle B to overtake A? Somebody unmute the mic and tell me again. Total time taken for the vehicle B to overtake A. Lamai?
100 seconds.
100 seconds. How do you get it? Isn't there? I'm so happy. Very good. Right. So you see this? Look at board. The total time taken for capital B to overtake A. They meet each other after 50 plus t seconds. After 50 plus t seconds, they were here at the same point. But at that time, B has a larger velocity of 12 and A has a smaller velocity of 9. As they are at the same time, as B has larger velocity, B will overtake A. So the total time taken for B to overtake A is 50 plus capital T. So that is 50 plus capital T is 50. We have found that T is 50. Let me erase this. And that is 100 seconds. So this is the answer. Please write this there. If we try to solve this problem using relative velocity, we have a small problem here. The problem is B is accelerating while A is traveling with a constant velocity. So if you try to apply the theories that we have learned in relative velocity, you will face that problem here. It has B has an acceleration, it has a constant velocity. But yes, possible, but sometimes it will be difficult. Once you have enough experiences of doing the frictions, I think graph will be the easiest. Once you solve, this is the second or third problem that you are that we solve for graph section. So therefore, it may be difficult. May I tell you a very easy method to overcome the difficulties here? Listen here. I have sent you theory paper 1, and I have discussed all the questions in theory paper 1 using equations. I have discussed all the questions in theory paper 1 using linear motion equations. Now you know the answers. You know everything about those questions. So within this week, try to answer the questions in theory paper 1 using the velocity time graphs. Then it will be easier. That is the easiest way for you to understand, because you know the questions, you know the answers, you know everything about those questions. The only thing is you solve the same problems using the graphs. So give a try to solve the questions given in theory paper 1 using the graphs. That's the easiest way, right? I think you have understood these 2 questions, and at the same time you can try the other 3 questions, 98, 99, and 100, and that will be the end of the tute. And I'll send you the next tute within this week. Within within this week I'll send you the next set of questions. Yes. Right, so that's it. We have completed everything.